So welcome to our notes on evaluating inverse trig functions. We first were introduced to the arcsine, the arccosine, and the arctangent functions when we did our notes on right triangle trigonometry, and that's where we learned that inverse trig functions are used whenever we want to find an angle measure when we're given the trig ratio. So what we're going to do in this lesson is apply these inverse trig functions to special angles on the unit circle. So in example 1, we're asked to find all the values for the arcsine of the square root of 2 over 2 over the interval. If it was radians, 0 to 2 pi. In degrees, it would be 0 to 360. And the sine is the y-coordinate. So when we look at the first quadrant, everything is positive in quadrant 1. If you recall our acronym, all students take calculus, sine is also positive in quadrant 2. So we're going to be finding solutions in quadrant 1 and in quadrant 2 because that's where the sine coordinate, the y coordinate, is positive. Okay, then we're going to determine which coordinate we should use, the x or the y, and, or if it was tangent, a ratio of them. Sine is the y value. So the angle that has a y value of square root of 2 over 2 in quadrant 1 is pi over 4 radians, or 45 degrees. So that's going to be our reference angle. We have a 45 degree reference. Okay, then we use that reference angle to find where the second quadrant answer is. So if half the circle is 180 degrees and we need to get into quadrant 2, then we're going to subtract 45 degrees, that's our reference angle, from 180 so that we're going the same distance back into quadrant 2. So 180 minus 45 is 135 degrees, and that would be our quadrant 2 solution to the arcsine of root 2 over 2. So we have two solutions, 45 degrees and 135 degrees. Okay, example B is radians this time, and we're evaluating the arcsine of -1/2. This is just on different notation for the inverse notation. Both of these are asking for the same function, the arcsine, and that is asking what angles on the circle have a y-coordinate of -1/2. So again, to our acronym here, all students take calculus. This time we're looking for the quadrants where the sign is negative, which would be the third and fourth quadrants. Tangent is positive in the third quadrant, cosine is positive in the fourth, so sine is negative in quadrants 3 and 4. Okay, next we want to find the reference angle, and that angle that has a y-coordinate of 1/2, and in radians that is a pi over 6 reference. So if I need to reflect my pi over 6 in quadrant 1, so I'll just dash it here. I want to reflect that into the fourth quadrant. One full rotation around the circle with a denominator of pi over 6, or denominator of 6 rather, would be 12 pi over 6. For a full revolution. So subtracting my reference angle of pi over 6 would give me 11 pi over 6. And that would be my first solution. My second solution comes from quadrant 3, and half the circle is pi, or 6 pi over 6 radians. So adding an additional pi over 6 for the reference angle would be 7 pi over 6. So those are my two solutions. My quadrant 3 angle, 7 pi over 6, quadrant 4 angle of 11 pi over 6. I'm having a hard time making a 6. There we go. And 11 pi over 6. Okay, now we're given that the sine of theta is -1. Theta is in quadrant. So to find the secant, it would be good if we knew what angle theta was. So let's go ahead and do the inverse to find it. So theta is equal to the arcsine of -1/2. And the y value we did in B that has a -1/2 in quadrant 4 is 11 pi over 6. So we saw that in our answer for part B. So now I know that theta is 11 pi over 6. And that's this angle right here. And in the fourth quadrant, the x value is positive, square root of 3 over 2. The y value is negative. So the coordinate at 11 pi, oh, that should be an 11 pi over 6 is square root of 3 over 2, comma, -1/2. So to find the secant, we need to know the ratio or the reciprocal of the cosine. So the secant of theta, and in this problem, theta is 11 pi over 6. That's the reciprocal of the cosine, and the cosine is square root of 3 over 2. So we flip that upside down, and then we're going to rationalize our denominator to get a secant of 2 square root of 3 over 3. And it's going to be positive because cosine and its reciprocal secant are positive in quadrant 4. Okay, so go ahead and pause the video and try this problem on your whiteboard or some scratch paper. The sine of theta is negative square root of 3 over 2. Theta is in quadrant 4. And to find the value of the tangent of that angle theta, following the steps that we just talked about. So first you want to find the arcsine of -√3 over 2. Figure out what that angle is in quadrant 4, and then find the tangent of that angle, remembering that tangent is the y coordinate divided by the x coordinate. Okay, when you're ready to go over it, then just resume the video. So welcome back. The arcsine of -√3 over 2 in quadrant 4 is 5 pi over 3. And the coordinate at 5 pi over 3 is 1/2, comma, -√3 over 2. So to find the tangent, we take the y coordinate and we divide it by the x coordinate. Dividing a fraction, or dividing by a fraction, means to multiply by the reciprocal. And then when we cancel the 2's, we get a negative square root of 3. And tangent is negative in quadrant 4.